this video is going to take a little more in-depth look of how the atom and the various subatomic particles were discovered throughout history. So, atoms could not actually be seen before the scanning electron microscope was invented, and that didn't happen until 1981. So even without being able to see atoms, the idea of the atom goes all the way back to ancient Greece. And so that's where we kind of begin. So in 450 BC, a guy by the name of Democritus, he was a Greek philosopher. He wondered what would happen if you cut an apple into smaller and smaller pieces. Would there be a point reached where the apple couldn't be cut into any smaller pieces? He called these uncuttable pieces. And in Greek, the word for uncuttable was atomos. So, 100 years after Democritus, a guy by the name of Aristotle, another Greek philosopher, he rejected Democritus' idea of the atoms. His idea was accepted for more than 2,000 years. And so this was mainly because Aristotle was much more influential than Democritus. So pretty much Aristotle's saying that Democritus was wrong lasted 2,000 years. So in 1800, John Dalton, the British chemist, revived Democritus' idea about atoms. He studied the pressure of gases and compounds, and what he found was that gases must consist of tiny particles that are in constant motion. And then when he looked at compounds, what he found was that they always exist in the same elements in the same ratio. So remember, when we talk about water, our ratio is H2O, so that means 2 hydrogen atoms to the 1 oxygen atom. So the only way, and they only work if the elements are made of tiny particles that can combine in a variety of ways. So he created what is called an atomic theory. And so basically, his theory says 3 things. First of all, it says all substances are made of atoms. These atoms cannot be divided into smaller pieces, and they cannot be created or destroyed. The second piece of Dalton's atomic law said that all atoms of the same element are alike. That means you can't tell one hydrogen atom from another, and they have the same mass. Meaning atoms of different elements are different, and then they will have also different masses. So basically, an atom of hydrogen is different than an atom of oxygen. His third piece of his theory said that atoms join together to form compounds. And a given compound will always consist of the same kinds of atoms in the same ratio. And so this theory is still widely accepted. And it's even still widely accepted today. However, there are some parts that are now known as not true. And so the first of that would be that atoms are the smallest particle. And so from the video before, we know that quarks. And gluons are really the smallest particles. So Dalton's theory is pretty good. So when he made up this theory, he also created models of atoms. Remember, they couldn't see them yet. And so what he thought was that atoms were tiny solid particles of matter. And he used wooden balls to model them. He drilled these holes in them so that they could be joined together with hooks so that he could model compounds. So when subatomic particles were discovered, Dalton's model became incorrect because there was nowhere in Dalton's model to place these subatomic particles since they were solids. So that brings in a British physicist named J.J. Thomson in 1897. His claim to fame is the discovery of the electrons. These were the first subatomic particles to be identified. And what he did was that he passed an electric current through a vacuum tube. And sometimes the vacuum tube is referred to as a cathode ray. And so what he discovered was when he did that, the beam went through here, and when he put a magnet up here, the positive charges attracted this beam, so that's why they're curving up, while the negative charges repelled that beam. So he concluded that the electric current consists of flowing negatively charged particles. And negative particles are all alike. And so you should really take a peek at this video that quickly demonstrates Thomson's experiment. So this led to Thomson creating a model of his atom. And he knew that atoms are neutral in electric charge. So he knew if they had the negatives, that they had to, the rest of the atom must be positive in order to obtain that neutral charge. So his model is called the plum pudding model. It's a British thing, apparently. For us, think more of like a chocolate chip cookie. Where the chocolate chips are the negative particles sprinkled throughout randomly, and then the doughy part or the cookie part is the positively charges holding everything together. Then fast forward a little bit, in 1899 Ernest Rutherford from New Zealand discovered the nucleus. He did something called a gold foil experiment, and he used alpha particles. Alpha particles just are particles that have a positive charge. And so he aimed a beam of alpha particles right here at a very thin sheet of gold foil. And so this would be about 4 atoms wide of gold foil. Think of like a piece of aluminum foil, but instead of it being made of aluminum, it would be made of gold. So then outside that foil, he placed a screen, that's what this circle is representing, that would glow when an alpha particle hit it. And so he discovered that some alpha particles pass straight through the gold foil. So those would be the ones hitting right directly back from the beam. So this piece of the screen was constantly glowing. However, what was more interesting was the few random ones that didn't hit that spot. So what caused those positively charged particles to bounce back? And what he figured is that in the middle of those atoms had to be a nucleus, and that nucleus had to be positively charged in order to repel those positively charged alpha particles. So Rutherford concluded that all the positive charge of the atom is concentrated in the small central area, and we call this now the nucleus. He later would discover the positively charged particles, or the protons, but it first began with the discovery of the nucleus. He also predicted the existence of neutrons in the nucleus, but he couldn't find them. And one of his students, James Chadwick, actually discovered neutrons, but not until 1932. So Rutherford's atomic model showed Thomson's model was incorrect. Instead, he had the electrons, or Rutherford put the electrons moving around the nucleus in random orbits. And his model is now called the planetary model. Because the nucleus is like the sun in the middle, and then the electrons are like planets orbiting around the planet, or the nucleus.